Hello out there. Welcome today on this beautiful day. So we are working on statistics, but the focus of this lesson will be data analysis. Okay. What does data analysis mean to you? What does data mean? It's collecting information. What does analysis? What does to analyze mean? I think it's to think about data, make some conclusions, some conjecture, arrive at conclusion, or advise what must happen, okay, when you analyze data. Does that make sense? I mean, even during our pandemic, people are employed to analyze the COVID data, and they'll give it to our president, and we'll decide whether we're on lockdown or to ease the lockdown after the analysis of data, okay? So that's what we're going to do. We're going to look at data, then arrive to some conclusion. Okay. So what does data analysis mean to you? Does it mean anything? Okay. I mean, I think it's taking data, whatever we've learned in statistics, data handling so far can be Whisker Plot, line graph, pie chart, frequency polygon, and represent data in one of the form and arrive to some conclusion by this analyzing data. Because if you have raw data, just random data around, what can you really achieve with the data? And another way of analyzing data, we can do our 5-number summary, our minimum value, quartile, median, and upper quartile. By having a Whisker plot, what can we do with a Whisker plot? Maybe if we calculate the semi-interquartile range and see the dispersion of the data before we make some conclusion. And just remember also the range, that, okay, the range is not a good measure of dispersion also, okay? That's what we're going to do. So analyzing data is collecting data, representing one of the form, then arrive at some conclusion, depending what are you trying to solve. Another question, is more electricity used in cold weather? What do you think about that? Yes? It could be, yeah, but because of winter, everyone is using a heater, maybe we're using more electricity, but I don't have sufficient evidence to conclude that. We need data to arrive at some conclusions. So for me to make an analysis to arrive and say, yes, we use more data during winter, I have to collect data from January to December, and I know our winter is around June, somewhere there, and analyze and say, yes, during winter, we use more electricity. That will be my analysis. So for now, it would be naive to say yes, because it's cold. Everyone is using heater. Is it sufficient to arrive at that conclusion? No, we need a proper analysis to arrive at that. If I can represent this as a line graph, frequency polygon of January, frequency table January all the way to December, and calculate how much electricity we use each month. Yes, and I say, yes, in June, June is the model class in terms of using electricity, then I can conclude that. But what if in December people are using more electricity, which is possible because people are on holiday, people at home. So one cannot assume. It could be true, it could be false, but with data we can have a proper reasoning because we have a true analysis. Okay. So what are we going to, in our data analysis, what are we going to focus? We'll start with comparing two sets of data. I can compare two sets of data, and how do we compare them? And from there, how do we arrive at conclusion? Okay, so we'll look at two sets of data and how to analyze that, okay, and arrive at some conclusion. By comparing two sets, it just means two sets of data can be boys and girls, could be two salesmen, okay, and so on. And we'll look at pie chart, because we know how to draw a pie chart. Okay, if you remember, a pie chart is more like a circle. How we draw it, we convert the proportion of what is given into an angle. Does it make sense? Okay, if I have 40 girls and 50 boys, I can draw that in a pie chart. I just have to say 40 divided by total, which is 90 times 360. I have to convert boys and girls into an angle, then draw a pie chart. But now we might have a pie chart. What does it mean to us? That's an analysis. We're given a pie chart. We read it. What does it mean? What can we conclude? What if there's change? What will happen? Okay, we're all together. So, and we'll also look at line graph, okay? And we'll look at box plots. Also, given box plots, what can we arrive at if you're given two box plots? But box plots are good if you want to compare two sets of data. They're very good for that. Line graphs, if you want to look at the trend, okay? I mean, if you go back, look at the COVID pandemic, all the way you can see it's more of a line graph. We had a peak, then the peak went down, then a second wave. A second wave when we record about 8,000 to 9,000 daily cases, a second wave was declared. But the question is, do you think the second wave will be higher than the first wave? How can we tell? We can look at that line graph and analyze. I think that can happen if we can get about 13,000 cases in the second wave. It will be, yes, worse than the first wave. Do we have provinces where the second wave is worse, is higher than the first wave? Yes, we do. If you look at the line graph, which is available all over the internet, you can see some provinces, the second wave, they have more infection than the first wave. And with restriction, they use the data analysis and put all the restriction to avoid that the second wave to be higher than the first wave. Do you think we're going to have the third wave? Is that possible? Will the second wave be worse than the first? It's a question. Can we really predict that? If you look at our line graph or data. Okay. So we need data to arrive at some conclusion and represent that. So line graph, we'll look at line graph also and analyze that, okay? And a bar graph also can be drawn to us and we can really analyze that. So let's look at some keywords, analysis, and distribution. I said analysis in this context, if data represented in this form, then I ask questions. What does it mean? Calculate all the measure of spread or measure of dispersion, your 5-number summary, and arrive at some conclusion. And by asking questions, is this better? Will the interquartile range, what does it mean? Why does this data have a lower interquartile range and the data have a bigger interquartile range? That's when we do an analysis. And when we talk about distribution, we're talking about distribution of data, which it could be symmetric, it could be skewed to the left, it could be skewed to the right. Okay, that's how data get distributed. So, we spoke about skewed, and we spoke about symmetric. When we talk about skewed, we're talking about skewed data, which could be to the left, right, and symmetric is when our whisker plot, this part of the block is the same as a block. So symmetric will be something like that if we draw a block, our whisker plot. If this area is the same as that area, this will be symmetric. And for skewed, it could be skewed to the left or right. Let's look at that. So if this blocks, if you look at this block is bigger than that. So this is skewed to the right. This is skewed to the right. But we can have a case of a whisker plot where we have a whisker plot. This is bigger, but this is smaller. And this will be skewed to the left. Okay. Remember, this is our whisker plot. And how we draw this using our 5-number summary, okay, which is minimum value, lower quarter, median, upper quarter, and the maximum value. Then you can decide on the skewness of your data. So in data analysis, we said we'll look at comparing data sets. Okay. We'll look at pie chart and line and box plot. So let's look at pie chart problem. There's a pie chart problem. Okay, what does it mean? So we have a pie chart here. What is important is to read it and understand. So we have here, we have prawns cocktail, an angle of 55 degrees. And we have bacon here, which is 35 degrees, when we can have ready salted at 135 degrees, cheese and onion, 50 degrees, salt and vinegar, which is 85 degrees. Okay. Does it mean anything? It's just a pie chart. What can I conclude there? By looking, I can see that ready salted, it's got a bigger area. But what does it mean? I can see that the bacon with 35 degrees is the smaller area. But what can I do with this? If I have a business and I want to order stock, based on my sales, I can see, oh, they're buying ready salted. That's what I need to order more. Does that make sense? I don't have to invest more into the bacon or the cheese and onion, which is third position in terms. Let's assume this was a tuck shop or something, or your spaza shop. Okay, but let's see what is required of us. So this is a pie chart. So what is the following pie chart shows the favorite crisp flavors for 72 children. Now we have more information. So representing data only without some more info also, what does it mean? I can conclude whatever I conclude. So this is specific to 72 children. A survey was taken. Then what? Is there a question? There are many questions we can answer. It depends. So let's see what we have to answer. I can create my own question. Can I say which one is the most nice? Maybe ready salted, but maybe not. But let's see what is happening. So how many children preferred ready salted? How many children? Can we really tell how many children prefer ready salted? So we know that ready salted, we have 35. Are we all together? We have 35. 135. So what we can do on our pie chart, so we have 35 for ready salted, which is an angle. We have to convert that into how many children. So we know that we have 75 kids for the 72 kids for the survey. 72 kids took part in the survey. So what are we going to do? The question is, what is the proportion of children who preferred ready salted? How many? We can't say 135 degrees, 135 degrees. It's an angle. But how many? So we have to convert that angle into how many kids actually took ready salted. So this is how we're going to do it. So we have to convert the 135 degrees into some ratio. So we know that angles around the pie chart, it's what? 360 degrees. So it's 135 of an angle of radisalted over 360. We put that in our calculator. Let's see what we get. So this is what we get, 0.375. So 0.375, okay, of the total, which is 72, take radisalted. Are we all together? Then this is what we do now. So the number of children who preferred radisalted is this multiplied by the total, which gives us 27 kids. Are we all together? Okay. I hope this makes sense, guys. This is another way. There are many questions you can answer from that pie chart if it's drawn for us. Initially, we had a pie chart. Then we can answer anything. What is the question? The question was, how many kids actually take radisalted? I hope to see you guys after the break. We'll look at more data analysis, okay? Probably something different. And remember, while you're sitting there, you need a pen and paper. You don't just observe. We do maths by pen and paper. Hope to see you soon. Hello out there. Welcome back once again. I hope you're ready and you have some energy to keep going. And remember one thing, to do well in this mathematics thing is to work consistency. It's not about doing lots and lots of hours on weekend, once in a blue moon. What is important is better to do 20 minutes every day than doing 5 hours on weekend. And we don't work hard because we have a test coming or a class test or exam. We work even though we're not writing an assessment. Consistency is the key to do better. That's the most powerful thing. And you don't observe, we just look at. You need a pen and paper to try some of the problem, to think with me. Think a little bit. Write notes down. Okay, try a problem. Have a calculator in front of you. Okay, that's how we get better. So now, we're still on data analysis. We looked at the pie chart, and there was a question which asked us how many students preferred salted chips, something like that. Now we're going to look at another data analysis. How can we analyze that and arrive at some conclusion? So on the data, we're comparing set of data, pie chart, we'll look at that. Line graph, we'll still look at that. And box plots and bar graphs. Now let's look at comparing data set. Comparing data set. So the distribution of set of data described how the data is spread out. You know, how the data is spread out. Do you have more of the data above the mean or below the mean, below the median, and so on. Okay. So two distributions can be compared by using one of the three average. So, and the range also. So example of comparing set of data, let's look at it. The number of cars sold by 2 salesmen. Each day of the week is shown below. So what you have Matt and Jamie. So they work for a dealership, they sell car. Jamie sold 5 cars on day 1. Day 2, he sold 7 cars. And day 3, 6 cars, 5, 7, 8, and 6. And Jamie went 3 cars. 6, 4, 8, 12, 9, and 8. By looking at the data, who is a better salesman? by looking at this, I mean, I can't even arrive to a conclusion. I can see that Jamie sold 3 cars, Matt went 7, 5 on day 1. Can I conclude based on that and say, yeah, on day 1, Jamie, you sold 3, Matt 5. But also, if you look at day 7, Jamie performed better than Matt by the same number of cars. Does that make sense? Because on day 1, Matt is better, Jamie 3, but on the last day, Jamie is better by the same amount of cars. What do you want to conclude? And also, if you look in the middle, I mean, there was Jamie better on day actually 5, sold 12 cars, where Matt 7 cars. A deviation by 5. Actually, this is the highest deviation we can see, which is 5 on the day. Can I conclude based on that and say, Jamie, he's a better salesman by using 1 day data? Can I? No, definitely. I cannot use one set of data and arrive to a conclusion, no, Jamie is a better salesman. What can we do here? Is the average better? Is the minimum and maximum better? Let's see what we can do. Who's a better salesman? What do you think? Do you calculate the average? The highest average is a better salesman? Do you calculate the range? Do you do Whisker plots? What do you do with the data? That's the most important thing. We're doing the analysis here. We're thinking about the data, and we want to arrive at some conclusion. Okay. So who's a better salesman? Let's look at that. So we have the table there for all the cars. Remember, these are the sales of the car each day. To decide which salesman is best, let's compare the mean car sold each day. So let's calculate the average. The mean is the average. Do you think the highest average is a better salesman? Do you think that? Let's see both means. So the mean for Matt, remember how we calculate the mean? To calculate the mean, we have how many days here? We have day 1, day 2, day 3, day 4, day 5, day 6, day 7. Okay. So to calculate the mean, we have to add how many cars they sold. Agreed? Divided by 7, because they were working for 7 days. Are we all together? So the mean for Matt will be 5, because day 1 he sold 5 cars. Day 2, 7 cars, so it's 5 plus 7 plus 6 plus 5 plus 7. He sold 7 cars, 8 cars, and 6. Divided by 7 because it was working for 7 days. Are we all together? Then put this on your calculator, which is 44 over 7, which is about 6.3 to 1 decimal place, if you round to 1 decimal. Okay. So the average, what does 6.3 mean? This means on average, Matt will sell, so we don't have 6.3 cars. Okay, we don't have 6.3. We have cars are 1, 2, or 3, 5 cars. There's nothing like that. There's no 6.3 cars. So on average, meaning he will sell 6.3 cars. He will sell about 6 cars. Less than 6 or more than 6, but I don't think more than 7 cars. On average, that's what will Matt perform at this company. What about Jamie? Let's look at Jamie. Jamie, we're going to do the same thing. We calculate the mean for Jamie. So this is the mean for Matt. The mean, we're going to take how many cars Jamie sold, divide by the number of days, which is 7. So let's take the mean for Jamie. The mean for Jamie will be 3, which is 3 plus 6 plus 6 and 4 plus 8 plus 12 because it sold 12 cars on day 5. Day 6 sold 9 cars and sold 8 cars divided by 7. Okay. Then we add that, we divide it by 7. We divide by 7. Then we get 50 over 7, which is 7.1 if we round to 1 decimal place. So the mean for Jamie is 7.1. And the mean for Matt is 6.3. Who is a better salesman? Who's a better salesman? So if we have both means there, can we conclude anything? This means on average, Jamie will sell 7 cars. Matt will sell about 6 cars. Daily average. It could be less. That's another thing average means. Okay? So on average, if we use average, Jamie is a better salesman based on average. Are we all together? But are you going to use average? Is average good for you, for your organization, for your business? Is something you'll consider? Okay. Or do you want consistency? It's okay that I sell 3 cars, 3 cars, 3 cars, 3 cars, 5. Or do you want me to sell 1 car, then 10? Oh, is that good? Is that what you want? I don't work hard on day 1, but I work hard some days. Or do you want consistency? That will differ from one organization to the other. But based on average here, Jamie is a better salesman. So this tells us that on average, Jamie sold more cars each day than Matt. That's the meaning of this. Just on average. Okay. So that's one measure we used. So can we look at something else? Okay. There's no mode for both. Okay, if you look at Matt, mode, it's a 5. You know, does it tell anything? Under Jamie, there's no mode, you know, no frequent number that occurred the most. So I don't think we can make any analysis from that. Okay. So what are we going to look at now? Still the same problem. The number of cars sold by 2 salesmen each day for a week is shown below. So still the same problem. We have Matt and Jamie. Still the same car. We're going to look at another analysis. The first analysis, we look at calculate the mean. And we said, what we arrived, we said based on mean, I think Jamie was better with 7.5, 7.1 average. But now, same question. Can you approach it differently and not look at the mean? Is that possible? I think it's possible. Because mean is not the only measure we can focus on. Okay. So let's do the range for each salesman and see. What does the range tell us? I think a range will tell us who's the most consistent. But is consistency better for you, or do you prefer average? What would you go with? Average or range? Okay, let's see that. And we said mode doesn't really tell us here. Okay. So if we do the range, just remember that the range is the maximum minus the minimum. So range is the max minus minimum. So it's the maximum minus the minimum. And remember, maximum is the highest value, and the minimum is the lowest value. Okay, that's how we calculate range. So if you look at Matt, what is the range for Matt? What is the Matt highest value? Matt highest value was 8. That's the highest numbers of cars he sold. And what about the lowest? The lowest is 5. That's for Matt. So Matt range is 8 minus 5, which is equals to 3. Are we together? That's the range for Matt. The highest minus the lowest, we get 3. What about the range for Jamie? What will that tell us? Okay. So let's look at the range for Jamie. And we know that the range also is still the maximum minus the minimum. Okay. So the maximum for Jamie is 2, the highest numbers of sales per day, and the minimum is 3. So this will be 12 minus 3. So 12 minus 3, which gives us 9. Okay? Matt range is 3. Jamie, 9. What can we deduce just looking at that? What can we analyze and arrive? Matt has the smallest range, Jamie the highest. This tells us that Matt is more consistent. He's more consistent. He will sell those 6 cars per day. If he will say he'll sell 5, he will sell 5. Consistency. And with Jamie, he's not consistent. There's like a huge deviation per day in how many cars he sells. Okay? Do you want consistency? Or do you want someone who sells lots of cars tomorrow and nothing the following day? All depends. Or do you want average? Okay. So the range of the numbers of cars sold each day is smaller for Matt. That's what we said. This means that he is more consistent or reliable salesman. He's a reliable salesman. That's what we conclude by using the range. Okay? So are you going to go with the range or the mean? Okay. So this is what we have. Matt mean 6.3. Okay, and range 3. Jamie mean 7.1. Range 9. On average, Jamie better. But on range, Matt better. And where do we go from there? I think, for me, I'll go with reliability. The average, very close together. I mean, 6 and 7. It's 6 and 7. The other guy will sell 6 cars. The other guy will sell 6. But the other one is even consistent. What do you think? The deviation on average is 1, but the other one is reliable. So I'll go with reliability and the 6. It will all depend. Okay, but that sounds better. So the better salesman, I would say, it's Matt. Okay, that's what we can. So we could argue that Jamie is a better salesman because he sells more on average. We could also argue that Matt is better because he's more reliable and consistent. Then, from there, what do? Is average or consistent? It will depend based on what you want, you value, average or reliability. Okay, guys, I hope to see you after this break. What are you going to do? We're going to look at another problem where we really analyze the problem deeper and see what is happening and arrive to some conclusion. Have we arrived at a conclusion here? Did we say Matt or Jamie? All depends. You can have different analysts with same data arriving at different conclusions. You can have a bank which predict the rent differently from another bank, which is possible. But what is important is to interrogate the data. See you after the break. Hello out there. Welcome back once again. Okay, so we're still on our data analysis. We looked at in the first part, we looked at the pie chart, analyzing his pie chart, and we looked at a problem where we have two sets of data, Matt and Jamie, two salesmen. We calculate their average, they're different. We calculate their range, different. What did we conclude? I said, you know what, it depends. One salesman was better on average, but the other salesman was better using range. So it really depends. You know, statistics is not static. The answer must be this way. It's fixed. Based on how we analyze that and argue, you can have two different analysts arriving different conclusions based on their data, how they analyze that. So we have to interrogate that, interrogate it more. And I don't think by using mean and range, we've done justice. We could actually do more and arrive at a better conclusion based on our analysis. Okay, let's look at another problem. So we're still on our data analysis. We compared data, looking at Matt and Jamie. We looked at a pie chart. We'll still look at line graph. Now we're going to look at box plot. So box plot. So we agree that box plot, what do? They compare two sets of data. They're very useful to look at the distribution. Okay. So we can compare data set by examining their box plot. Box plots are useful because they're comparing the location, the spread, and the shape of the distribution. The shape, we're talking about the skewness when you talk about the shape. Symmetric, negative skew, or positive skew. Remember the Whisker plot. Let's look at this Whisker plot. Remember this is Q1 here, okay? It's Q1, Q2, Q3. If this part is the same as that part, the distribution is roughly symmetrical. Agreed. Another way, if Q3 minus Q1, this means it's approximate, is the same as if Q2 minus Q1 is approximately Q3 minus Q2. This does not have to be exactly exactly the same, but almost equal, then that will be symmetrical. Okay. And what about negatively skewed? Negatively skewed, by just looking, you can see that this part of the box is bigger than this part of the box. More of your data is this side. And remember, this is the median, which is Q2. Are we together? To see that, you can say Q2 minus Q1, which is this area, and Q3 minus Q2, which will give you that. So this is negatively skewed. We looked at symmetric, negative skewed. Let's look at positive skewness. So positive skewed, if this part is smaller than that part, you can see this is bigger and this is smaller, then this is positively skewed. Or what you can do, you can say if Q2 minus Q1 is smaller, this is smaller than Q3 minus Q2, we can say this is negatively skewed. So we have a problem here. Gemma recorded the height in centimeter of girls in the same class and constructed the box plot or whisker plot from the data and the box plot for both boys and girls are shown. So what do? We go in class, we measure the height of the girls and the boys. Then we calculate the 5-number summary for the girls, the 5-number summary for the boys. We draw 2 whisker plots. And this is what we get. We have boys plot and girls plot. What does that plot mean? What does it mean? If we have heights of girls and boys, I mean, what can I do with it? But if I can represent that, I can do some analysis. So this is what we have. By looking at this, I can see that in this class, who is the tallest? Boys or girls? The boys, because remember, this is the minimum, and this is the maximum. This is the minimum, and this is the maximum. So the tallest in this class, it's a boy, because the maximum, it's a boy. But the minimum, it's also a boy. Are boys taller than girls? Can I tell based on that? I don't think I can. Okay, let's see what we have for some questions. Use the box plot to choose some correct statements comparing the heights of the boys and girls in this class. And we have to justify our answer, guys. Justify, give some reason. The girls are taller on average. Are girls taller on average? What can you say? And how do I calculate the average? I don't have the raw data. If you look at the whisker plots, okay, you have more data. From 160 to 170 of the data is there. And remember, this is 25% of the data, and you have another one there. So actually, on average, if you look at this, girls won't be taller on average. Boys will be taller on average. Okay? Are boys taller on average? Yes, I think so. If you look at the boys, okay, look at the skewness. It's skewed to the left. But look at the lower quartile, it's close to 160. Are we together? Okay. So, do girls show less variability in height? Now, we're going to look at the range for both questions. If you look at the range, I think this is, if you look at the range, this is 180. Which range is the biggest range? To answer the question, we have to look at the range to answer the question. Which whisker plot has the highest range? The smaller the range, the closer they're together in terms of height. The higher the range implies, yes, we could have just a tall boy in the class. Okay, does make sense? And makes the range bigger. So I think that the girls' range is smaller and the boys' range is bigger. Okay. Is the smallest person a girl and the tallest is a boy? By looking at the whisker plot. So to do that, we'll have to look at the minimum and the maximum. And remember, the whisker plots represent the 5-number summary, where we have the minimum and the maximum. So if we look at the minimum is there, and the minimum a girl is there. So actually, the smallest in terms of height is a boy, because the minimum, the smallest, now the smallest is somewhere there, it's a girl, making a mistake. So the smallest is a girl. Are we together? Because got the slowest minimum. Are we all together? Now, is the tallest a boy? The tallest, we're going to look at the maximum. We'll look at the maximum. Okay? So the maximum, look at the maximum for a boy, it's close to 190. And the maximum for a girl is close to 180. Based on using maximum, we can see that the tallest is a boy, based on this Whisker plot. Are we all together? Okay. So guys, this is the end of our session. I will encourage you guys to keep working hard, consistency, okay? And there's so many careers in statistics. And I mean, I think in data analysis, and this is the world of data. We're in the fourth industrial revolution of the 21st century. The fourth industrial revolution is about the collaboration of human and machine. So any person needs to have knowledge of data. You want to be an artist. You want to be a psychologist. You want to be a writer. Data analysis is not for engineers, maths, or people who want to study statistics. It's for any human being who is able to analyze data and make decisions. So it's important that we keep learning about this data. And remember, guys, to keep working hard, and being consistent is the most important. And I hope to see you soon. Goodbye.